Okay, today we are going to talk about Venn diagrams and mutually exclusive events. First thing is a definition of mutually exclusive events. What that means is that they are two events or outcomes that cannot happen at the same time. For example, it's either raining or it's not raining. Those two things are mutually exclusive events. They can't happen at the same time. Here are a few examples. So if I go through numbers 1 and 2 with you, please pause the video after that and do 3, 4, and 5, and then start it up again and I will go over the answers. So for number 1, dog or cat. You cannot be both a dog and a cat, which means yes, they are mutually exclusive events. Number 2, an even number or a 6. Those ones are not mutually exclusive, because an even number could be a 6. They could both happen at the same time. Take a minute, pause the video, and try the last 3. Okay, number 3, an even number or a 5 number. Yes, they are mutually exclusive. 5 is never an even number. Number 4, a club or a face card. No, they are not mutually exclusive. Um, the Jack of Clubs is a face card that is a club. Number 5, a club or a red card. Yes, they are mutually exclusive because clubs are all black. Now we're going to talk a little bit about Venn diagrams. If I were there, we would be doing this in class, but I'll just pull up some random data. Let's say there are 30 students. 19 students have brothers, 16 have sisters, and 10 have both, okay? So the first thing I want to do is put together a Venn diagram for this situation. So we're going to draw 2 circles that overlap each other. Circle on the left is going to be for if you have a brother. Circle on the right for sister. Um, it says 19 people have brothers, 16 have sisters, and 10 have both. So the 19 is going to go here, and the 16 is going to go here. Both always goes in the middle. That means and. Okay. If 10 people have both a brother and a sister and there are 19 people with brothers total, that means there are 9 people that have only a brother. Same thing for sisters. 16 people have sisters, 10 have both brother and sister, so there's 6 there. The only other thing we need to figure out is what's going to go on the outside of all of the circles, which would be neither a brother nor a sister. So if you count the 9 plus 10 plus 6, you get 19 plus 6, which is 25. So 25 people have either a brother or a sister, which means 5 people have neither. Okay, so now we have some questions that we are going to answer. First one is the probability that somebody has a brother. Remember, this is probability, so we're going to put this into a fraction or a decimal form. We'll put this one into a fraction form. 19 people have brothers, and there are 30 people total. Okay. Probability of having a brother but not a sister. So that's that 9 that is under the brother but does not include the brother and sister. So there's 9 people with a brother and not a sister out of 30, which if you left it as a fraction simplified to 3 out of 10, and the decimal would be 0.3. Okay. Um, take a minute, pause the video, try the last 4. Okay. Probability that they have a sister and not a brother, so that's the opposite of the one we did previously. That's 6 people have a sister but not a brother out of 30, which simplifies to 1/5 or 0.2. Probability that they have a brother and a sister, that's the one in the middle, that's that 10. So we're going to do 10 out of 30. Okay, out of the way. 10 out of 30, which simplifies to 1/3 or 0.3. Repeating. Second to last one, brother or a sister. So that's when I take the three pieces inside the circle and add them up. 9 plus 10 plus 6, which is the 25. Brother or a sister includes all three of those pieces. So I'm going to take 25 out of 30, which gives me 0.83 with the 3 repeating. And then the last one is the probability that they have neither. We determined that 5 people have neither, which is 1/6, or 0.16 repeating. Here is a similar example. I would like you to take a minute, fill in the missing pieces of a Venn diagram. You should fill in the green circle, the green part of the circle on the left side. You should fill in the number that goes next to cat, and fill in the number on the outside that has neither. Pause the video, take a minute to do so. Okay, we're back. This whole green circle right here, the probability of having a dog in that whole green circle is 0.7. To figure out what goes in just the left side of the green circle, so not including the middle, I'm going to take 0.7 and I'm going to subtract that 0.5 from the middle, and I get 0.2. Okay. So then to get cat, I'm going to do exactly the opposite. So the number that goes next to cat, I'm going to take the 0.5 in the middle. There's 0.5%, the probability 0.5 people have cats. 0.3 have only cats, so the 0.5 is cats and dogs, 0.3 is only cats. Add them together and you get 0.8. Okay. And then to figure out if there's anything that goes on the outside, you add those three numbers in the middle together, 0.2 plus 0.5 plus 0.3. You get 1, so technically there's 0 people that have neither out here. Okay. Probability of having a cat, now we just use that information that we found and answer these questions. The probability of somebody having a cat, that's the 0.8 that's up by the cat. Probability of a cat and a dog, that's that 0.5 that's in the middle. Probability of having a dog and not a cat, that's that 0.2 that we filled out on the left. Probability of a cat or a dog, that's when you add all three pieces on the inside again. That's 1. Everybody that was surveyed has either a cat or a dog. And then the probability of neither is 0. Next, we're going to do a set of definitions. This is our set theory notation. So we have two different symbols. One is intersection, and that's like it looks almost like an N shape. Um, that means and. Okay, the N shape means and. So the example, that probability of having a cat and a dog. Okay, if we looked at our previous example, cat and dog was that number in the middle, which was the 0.5. So that N shape means and. This other one, a union, which is a U shape, that means the same thing as or. So probability of having a cat or a dog, that was when we added the three pieces together and we got 1. Last example we have, this one's a little bit trickier because you may notice that there are 3 circles within our Venn diagram. So just to give a little explanation, um, the circle on the top left is for orchestra, circle on the top right is for band, and the circle on the bottom is for choir. The place in the middle that's labeled as a V, in that place, somebody does all 3 of those things. Okay, the place labeled W would mean that somebody is in orchestra and choir. Place labeled X means they're in band and choir, and then labeled T would be orchestra and band. S is only orchestra, U is only band, and Y is only choir, and then Z is none. So If we look to the left where it says a bunch of different probabilities for us, I'm going to take a minute and I'm going to talk through how you would fill in all of these probabilities on your Venn diagram. So if we start with the probability of band or choir, okay, that would be anything in the band circle, T, U, V, and X, anything in the choir circle, we already counted V and X, so then also W and Y, all of those places added together would be 0.8. So we can't do that yet because we don't know any other information. The probability of not being an orchestra, so that's anything outside of the orchestra circle, that would be U, X, or Y. That would be U, X, or Y. It says in the problem that everybody is in music, so the Z on the outside is going to be 0 regardless. So U, X, and Y would be not orchestra. Again, 0.6, but we don't know how to split up that 0.6 yet. The probability of being in choir and not orchestra and not band is 0.1. So that 0.1, I'm going to put in place of this spot right here. Okay, that's the only choir spot. So that one we've done, we can cross that off. The probability of being in band and choir is 0.2. Okay, so band and choir, that includes both X and V, those spots there. So I can't fill that in yet. It then says orchestra and band are mutually exclusive. If you remember back to your notes a few slides ago, mutually exclusive means they can't happen at the same time. So there is 0 people that are in both orchestra and band. Okay, so orchestra and band intersect in these spots here. So there's going to be a 0 here and a 0 there. Okay, 0 people in both. Now we can look back at some of our other problems and we can fill in some more information. Okay, so if we look at the probability of being in band and choir, the one above that is 0.2. Well, I said that includes both the X and the V. Because the V is 0, that means I'm going to have the total 0.2 in the spot with the X. Okay, I'll use a different color. I think that green's hard to read. Cross that off first. The probability of not being an orchestra, okay, not being an orchestra is 0.6. Remember that includes U, X, and Y. So the U, the X, and the Y, that 0.2 and that 1, have to all add up to 0.6. So the 0.2 and 0.1 already make 0.3, which means I have another 0.3 left over for here. Cross that off. And then the last piece says the probability of being in band or choir is 0.8. So that includes both the full band circle and the full choir circle. The only piece we haven't filled out for that is the W, which means all of the pieces we've filled out plus the W has to be 0.8. So I have 0.3 plus 0.2 plus 0.1 plus 0 plus 0, which gives me 0.6, which means I have 0.2 left over for that spot in the W. The only other piece we need is that S, the S piece being an only orchestra. To do that, we need to take all of the pieces we've already filled in. Those pieces plus the only orchestra piece have to add up to 1 because everybody has to be included in there. So I know I have 0.8 in both band and choir, in band or choir, which means that there's 0.2 left to be an only orchestra. Okay. That is everything from the lesson. Your homework is the Venn diagram worksheet. I will see you tomorrow.